Let me tell you a little bit of a story and go down Python memory lane. Now, Python is one of the most popular programming languages. I think now with AI and with all the LLM stuff that's happening, Python has become even more popular. There is a very popular library in Python called PyYAML. PyYAML is a library that allows you to parse and serialize and deserialize YAML. Now, PyYAML had a huge security issue in the 3.x version or anything under the 5.x version. And this was crazy stuff, right? Now, what used to happen in PyYAML just under 5.x was that so let's say you had a YAML that you wanted to load and you used PyYAML to load that YAML. So let's say somebody was uploading a YAML statement or YAML file or was trying to parse some YAML in their Python application, and they used YAML.load, which is the standard function that you use YAML.load. And there were some malicious parameters or malicious input inside that YAML that would just literally remote code execute on that particular server. So let's say the YAML had an instruction that says use bash and then run this particular command or do whatever else. It would literally just do that, right? It would deserialize and it would have all kinds of massive impact. It was simply because it used to parse certain system instructions from YAML, and the library just worked that way, right? You had another function called safe_load, which was a safe version of that behavior. Now, this was obviously a huge problem simply because most developers out there, most guides out there, most of the implementation instructions out there would default to people using YAML.load. When people were using that YAML.load, they were vulnerable by default. What they did, very interesting thing that the library maintainers did in version 5.x and above, is that they changed it up, just one change. They just made the load function the secure by default function, and they created another function called unsafe_load. And by doing this, what they did was everybody who was using load is now secure by default. And if you wanted to use the unsafe functionality, let's say you had a genuine need for it, you would have to use a function called unsafe_load. And you would clearly know that this is not a good thing that you want to do. You need to be very careful while using it. But the idea was that they made it secure by default because load, the default way of calling it, was secure. And the unsafe_load was clearly called out as saying, hey, this is not good. Don't use it. But if you really have to, you need to know what you're doing. This really was a huge change to the entire Python ecosystem. In fact, there were libraries related to DevOps and other frameworks that were vulnerable because of this flaw. And overnight, this stopped being an issue because the default functionality became the secure functionality. And this is what I mean. This is a classic example of a secure by default.